Good evening, everybody. I hope you had a wonderful day until now. Force is equal, pressure is equal to force over area. What's the force? Force is going to be equal to either weight or mass multiplied gravity acceleration divided by area. Mass, it comes with kilogram unit. G is the gravity acceleration. It has unit of meter over square of second. And A, it comes with m2 units. So final unit for pressure, it will be equal to kilogram multiply m divided by s2 and whole base divided by m2. The numerator, call it Newton, and we divide it by m2, and that one will be the unit of pressure. So Newton over the square of meter is one of the units that you can use for pressure. Okay. Again, force is equal to weight or mg. Force, you can write it as ma. What's the difference between mg and ma? Ma, if you are moving or the object is moving on a surface, then the force is going to be equal to weight, the mass multiply acceleration. If it's a free fall, it will be mass multiply gravity acceleration. And A is the area that we're applying the force on it. So I can go up through it like this, and I'm going to say I have area. Let's call it A, and here we have B. And if we want to define, the area is going to be A multiply B. Okay, A, it comes with meter unit multiply meter. For B, we get m2. Next, we said pressure is equal to force over area. We know the unit for area is m2. Let's go after the force. Force, it can be either ma, or force, it can be written as mg. It doesn't matter which one you go with. But let's define A. A is equal to velocity multiply time, and velocity is equal to distance divided by time. Okay, or x divided by time. Distance, we show it by meter, or displacement by meter, and time is second. So the unit for velocity is meter over second. And if you replace the velocity by meter over second, you get this: meter over second divide by, again, second. That one, it will give you m over s2, which is the right unit of A. And for G, again, G is a gravity acceleration, is 9.80 meter over square of second. And we said pressure is equal to force over area. So you go kilogram for mass multiply m divided by s2. That's in Newton, okay, equal to Newton, and all this divided by area, which is going to be m2. So we get Newton over m2 for unit of the pressure. Now, on the right side of this slide, you see that we have a beaker. The beaker, it has mercury in it. So what we do, we take in a tube, and the tube is completely vacuum. There is no air, anything in it, completely vacuum. And we flip the beaker inside, we flip the tube inside the beaker of, mercury. Now, all this measurement was taken on the shore of a sea or ocean. Okay, it has to be sea that's connected to ocean or ocean, because we want to, we need to be careful about the height of that area. So we're assuming the height is equal to 0 or the sea level. If you do that experiment, on height equal to 0, in that case, you will see that the atmosphere, it will push the mercury, and mercury start to go up inside the column. So we have a force here. Force is force of the atmosphere is pushing the mercury to go down, and mercury, it will start to go up inside that column. Nothing is going to stop it. But then, upon increasing, the level of the mercury, you start to build mass, or you start to build like height, and that height, it will feel the gravity. Gravity, it will pull it down. And keep it in mind, by increasing the height, you're creating pressure as well. As the height goes up, the gravity force is gravity force on it is decreasing. We will reach one level that I should not say. So sorry, I should not say gravity force is increasing. As we go up, as the mercury is going up, okay, we're building too much mass. Let me write it here. Right here. I think I have more space to show it for you. So let's say this is our beaker. Okay, and you have mercury there. So this is mercury. And next, you will draw a tube. Okay, so let's assume this is our tube. And okay, I'll make it smaller. Tube is sealed. From the top is sealed. Right now, it's completely empty. Now, atmosphere, which will push. It will push the mercury from each side. Okay. So we say this is the force of the atmosphere. And effect of that force, mercury, it will start to move up. Okay, so the mercury, it will go up until it will reach one level. Let's assume mercury went until this level. Okay, and here we had mercury. Okay, so as you see, mercury went up. We reached to this level. When we measure, when we measure it, it says, the height of that column. Okay, I'm talking about the mercury. Height of that mercury inside the column from the surface of the mercury is equal to 76 centimeter or 760 millimeter of mercury. So if that level here, I'm talking about this. If this height reached to h equal to 76, h is equal to 76 centimeter, which is equal to 76 millimeter of mercury, it will stop and it will not go up anymore. Why? Because gravity is pulling it down. Okay, gravity is pulling it down. Okay, now when we reach to this level, okay, gravity force, it will be equal to the force of the atmosphere. So before that level, 76 centimeter of atmosphere force was stronger than the gravity, and that's the reason mercury was going up. But then when we reach to 76 or 760 millimeter of mercury, and gravity force, it will be equal to the atmosphere force, and there must be extra force to push the mercury up. We don't have that force. That's the reason mercury is not going to go up anymore, and it will stop. Whenever mercury stops, we will read that height, and we say 1 atmosphere is equal to 760 millimeter of mercury, which is equal to 760 torr. That means 1 millimeter of mercury is equal to 1 torr. Okay, so 1 millimeter of mercury is equal to 1 torr. Okay, what's a torr? Torr comes from, I believe Torricelli is the Italian name, the guy that he came with this setup, and he did this measurement for us. So from now, anytime we talk about pressure, we say 1 atmosphere is equal to 760 millimeter of mercury. Why do I add mercury here to the millimeter? Because density of mercury is different than density of other compounds. If you replace mercury by, say, like ethanol in water, the height, it will be different. Why? Because mass of mercury is different than mass of water. So if I replace water maybe goes, to a higher level, and higher than 76 centimeter. It can go, way bigger. I have no idea what's going to be the number, but because the mass of water is less than mass of mercury, mass of same, in that case, I'm going to say like whenever I'm going to report the atmosphere, I have to mention what's the millimeter of, a millimeter that I'm talking about. It is mercury, ethanol, water. But all the time we will be talking about mercury, which is a standard, standard actually kind of definition when we're talking about pressure. Okay, pressure of liquid. When you dive in a pool, you will feel that there is a pressure in your ear, and you cannot stay long time underneath of that water. And the reason for it, because all the time you feel pressure, and that pressure, it can give you some headache. And after after actually staying a long time underneath of the water, you feel that pain, and you have and you feel like you need to actually come up and to get rid of that force. The pressure for liquids, we can define it through rho g. H, rho is density, g is a gravity acceleration, and h is the depth. Okay, so as you see, rho, it will be kilogram over cubic centimeter. Talking about this, yeah, kilogram over cubic meter. Height, it has to be in meter, and gravity acceleration, all this will be given to you, and it will be 9.80 meter over square of second. So if if they ask you a question about density of liquid, check the unit for density and the depth, or height. Okay, so for example, in this case, they give us the depth is 186 feet. It's not meter, so underline the feet. Say this one needs to be meter. Next thing is they gave us the density of water. Density of water is given in gram over milliliter. We need it to be kilogram over cubic meter. So fix that depth and density. Okay, let's go after it. So the given data is going to be equal to 186.0 feet. So I'm going to say H, 186.0 feet. 1 feet is equal to 30.48 centimeter, and 100 centimeter equal to 1 meter. Okay, so you go H equal to 186.0 feet. 1 feet is equal to 30.48 centimeter. Get rid of the centimeter, transfer it to meter, and you say 100 centimeter equal to 1 meter. So now you can cross centimeter by centimeter, and that one will give you the final answer equal to 56.69 meter. Okay. Next one, it will be the density. Density is given and is equal to, I believe, was 1.012, and the unit is a gram over milliliter or gram over centimeter. Gram over milliliter is equal to gram over cubic centimeter. So simply, I'm going to say cubic centimeter. Okay. Let's transfer it to kilogram over cubic centimeter. Now we go 1,000 gram equal to 1 kilogram. So now gram is gone. We need to transfer the cubic centimeter to cubic meter. Last thing that I need to do, I'm going to say 1 million cubic centimeter equal to 1 cubic meter. So cubic centimeter will be canceled by cubic centimeter, and this one will give us the final answer equal to 1.012 multiplied 10 to the third, and the unit is kilogram over cubic centimeter. So I got the H and D with the right units. Now I need to go after pressure, which is going to be equal to rho GH, density multiply G multiply H. Density, we just got it, 1.012 multiplied 10 to the third kilogram over cubic meter. You multiply it by H, which is 56.69 meter, and the last one multiplied by G, which is 9.8 m over S2. And that one will give you final answer equal to, I got it, 5.623 multiplied 10 to the third, and the unit is kilogram over, kilogram. We can go kilogram over meter. We can go on meter second. And so we can write this one, divide by, oh, hold on, okay. I have M2 actually here. So I have M3 multiply M multiply M. So I get M2 there. Okay, I'm going to cancel one of these and write it here. Is it going to be correct? Yes. Okay, which is going to be equal to Newton over M2. Okay, Newton over M2. So what it did actually, I want to erase this one, rewrite the unit. Unit's supposed to be this. Write it with a different color. Kilogram multiply M multiply the second M, which is this one. Okay. So 1 M, second M here, I get 2 M. So you can say 2, divide by S, divide by M3. If I cross M here, one of the M, just one of them, have one here, this one will be 2. Why did I do it? Because I want to define Newton. This one, it will be Newton, and denominator it will be M2. Okay. Does it matter really to write it Newton over M2? No, it doesn't matter. But like I just wanted to show you how to write it in Newton over M2. You can simply say this. I have M2 S divided by M3. Okay, I can write it as kilogram divided by M multiply S2. Again, I can write it as Newton over M2. Okay, it's just like you need to define that, here, Newton. Now I'm going to show you actually how to measure pressure of, again, sample of gas. Okay, let's assume you have a balloon or you have gas in a chamber and you want to, measure pressure of it. And the way we do it, we hook it to a tube that it has mercury in it. And at the beginning, level of mercury will be equal on both sides. So let's say the mercury at the beginning was here on both sides, and you call this one 0. It depends, the pressure of the gas, whether is higher than a pressure of atmosphere or less. You see some displacement with the mercury. It can get, closer to the gas or to the balloon, or maybe the balloon is going to, the pressure inside the balloon, it will push the mercury, and mercury start to heat actually to outside. Okay, if mercury is moving in this direction, we say the pressure is a positive number. Okay, that means the pressure of the atmosphere is less than pressure of the gas, or it's, this one is actually the gas. Okay. Your sample has higher pressure than the atmosphere pressure. Okay, how can I measure it? And that's going to be the question that I will go after it. Okay, let's assume you hooked it to a U-tube. That's a seal. Okay, here is seal. In that case, entire of the gas, entire of the pressure of that gas will be used to push the mercury. Okay, it will push the mercury until it will stop somewhere. Okay. Now you started, for example, from here. It has to be even at the beginning. Okay. And as you see, gas moved the mercury by this level down, and same amount up on the right side. The entire displacement, it will be, let's call this one H1 and call that one H2. So the displacement will be H1 plus H2. If I know H1 and H2, simply I can transfer them to millimeter of mercury, and that's going to give me pressure of the the gas. So let's assume H1 is 2 centimeter. That one is going to be also 2 centimeter. So we say the total H is going to be equal to 2 plus 2, it will be 4 centimeter. So total one you can say is 40 millimeter of mercury. That means pressure of the sample or gas is going to be equal to pressure of H, which is equal to 40 milliliter of mercury. But if the tube is open to the air, then in that case, the gas will not only push the mercury, it has to fight with the force that we get it from the atmosphere. Remember, outside or the atmosphere, it will push the gas down. So you get a pressure, which is equal to pressure of atmosphere, pushing the mercury down. And here we have pressure of gas that's going to be used to push the mercury toward to outside or to the atmosphere. Okay. So in that case, we say pressure of the gas is going to be equal to pH plus P atmosphere. Okay. After example here, first one, pressure of gas or sample is higher than pressure of atmosphere. How do I know? Because mercury went up. Okay, mercury is getting close to go outside of that U-tube. But the second one, pressure of gas is less than the pressure of atmosphere. So in this case, we say we have a negative pressure. That means it's less than outside pressure, and we need to, we need to actually fix this one. Okay. So first one, I see the displacement is something around 3.5 one side and 3.5 the other side. So totally it will be 7. And that one, you can say 2.2 or 2.25. Okay. Let's handle the first one, and we will go after the second. So the first one, we said H is equal to 7 centimeter, which is equal to 70 milliliter of mercury. Pressure of gas is going to be equal to P atmosphere plus pH. pH, we got it 70 milliliter of mercury. Pressure of atmosphere, they need to give it to you. Let's assume this case is 760 milliliter of mercury. So you go P gas equal to 70. Give me first one actually is atmosphere. So it will be 760 milliliter of mercury plus 70. This one it will be 830 milliliter of mercury. If you want to know it in atmosphere, just simply divide the number by 760 to get 1 atmosphere. Okay, 760 it will be equal to 1 atmosphere, and the final answer for this one I got it 1.092 atmosphere. Okay. Second one, I told you the pressure of the gas is less than pressure of atmosphere. So you can't say just simply pressure of gas is equal to pressure atmosphere plus pH. That's not going to be true, because in that case you are adding pressure, you're adding pH to the atmosphere, and if you add them for sure P of the gas, it will be higher than the pressure of the atmosphere. In order to fix it, I'm going to say I have a negative pressure. That means I need to subtract the pH from the pressure of atmosphere. And the way I will fix it, I don't want to change the formula. Simply, I will use the same formula, but I'm going to say H is equal to minus 4.5 centimeter of mercury, which is equal to minus 45 milliliter of mercury. So I gave it negative to show that the displacement is to the gas sample, not to the atmosphere. That means we have negative pressure. Okay. So you say P gas equal to 760 minus 45 milliliter of mercury. Answer is equal to, I got this one, okay. Which is equal to, if you transfer it to atmosphere, it will be 0.9408 atmosphere. So the key was this, okay, the negative sign.